Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about one sample significance tests for a proportion. Here's the problem we're going to be looking at. The AP scores for each state are released by a college board every year. According to this report, in 2016, 51.86 of the 1,100 students who took the AP statistics exam in Idaho earned a passing score. In the same year, Mr. Morehouse had 68 students take the AP statistics exam, and 42 of them earned a passing score. Mr. Morehouse wants to know if there is convincing evidence that the proportion of his students who earn a passing score on the AP statistics exam is higher than the state proportion. We're going to use an alpha of 5%. Step one is to define our parameter and hypotheses. We're going to let P equal the proportion of Mr. Morehouse's students who earn a passing score on the AP statistics exam. Our null hypothesis is that P equals 0.5186, and the alternative is that P is greater than 0.5186. Note that the alternative is a greater than because Mr. Morehouse thinks that more of his students passed than the state. That makes this a one-tailed test. For our conditions, we're first going to state the procedure we are going to run. This is a one-sample z-test for P. Random sample. We're going to treat Mr. Morehouse's students as a random sample. Technically, they are not, but we're going to kind of gloss over this one for this problem. The 10% condition is met, and I've showed the work there. 10 times 68 is 680, which is less than the 1,100 students that took the exam in the state of Idaho that year. The LCC is met, and we're showing the math that says that there were at least 10 successes and 10 failures. Now note, this is a little bit different than confidence intervals where we use the sample proportion or sample results to justify the LCC. Since we have a proposed population proportion of that 0.5186, we need to use that value to verify the large counts condition. For our calculations, if we're going to do it by hand, we have a p-hat of 0.6176. This comes from the 42 divided by the 68 that are in the sample size. Putting that into our test statistic Z formula, we would get a test statistic of 1.6339. We could then use Desmos or a Z table to find the p-value. However, since we need to use Desmos to convert that Z into a p-value anyways, we might as well just use Desmos to run the test itself. So I'm going to go to my inference menu here and select Z-test for proportions. We had 42 successes out of 68 total students. I'm going to click Create Test and select the Significance Test drop-down menu. I'm going to change the null hypothesis to the 0.5186 that we had for our problem, and we had a right-tailed test because this was a greater than alternative hypothesis. You can see we get a p-value of 0.051, just above 5%, and our test statistic is Z equals 1.635, the same that we found by hand earlier. Now, before we talk about the conclusion to this problem, I wanted to show you this cool picture of some rainbow bagels that I made a few years ago. They're quite interesting looking, but they didn't taste very good at all. In conclusion, we're going to say that the p-value of 0.0511 is greater than our alpha of 5%. Thus, we fail to reject the null hypothesis in favor of the alternative hypothesis. There is insufficient evidence to suggest that P equals the proportion of Mr. Morehouse's students who earn a passing grade on the AP Stats exam is higher than the state proportion. Thank you for joining us, and have a great day.